Assistant Professor at Delta Institute of Engineering and Technology. Today we will discuss few more topics of partial derivatives. So let's begin with the first topic, definition of partial derivatives. A partial derivative of a function of several variables is the ordinary derivative with respect to one of the variables when all the remaining variables are kept constant. So for example, if we have function of two variables, that is f of xy, okay, and if we have to find fx, that is partial derivative of function f with respect to x. So in this case we will keep y as constant, okay, and if we want to find fy, that is partial derivative of function f with respect to y, so at that time we will keep x as constant, okay. So this is the meaning of the statement we have discussed. Now let's consider a function fxy. Then the first partial order derivatives of f are given by fx. This is the formula using definition. So fx is equals to del f by del x is equal to limit delta x tends to 0 f of x plus delta x comma y minus f of xy upon delta x, and fy is equal to del f by del y equals to limit delta y tends to 0 f of x comma y plus delta y minus f of xy upon delta y. So whenever we have to solve derivative using a definition method, so if we want to find fx, okay, so what we will do, we will find this limit. So for this, in place of x we have to write x plus delta x. We have to simplify this limit, and to find fy, that is partial derivative of function f with respect to y, we will apply this formula, okay. So let's begin with example. First example is, if f of xy is equal to x square y plus xy square, then find fx. Here we will solve this example using definition, okay. So firstly, f of xy is equal to x square y plus xy square, okay. Now here we have to find del f by del x, okay. So the formula is what? Limit delta x tends to 0 f of x plus delta x comma y minus f of xy upon delta x. Okay, so now in this function here, in place of x we will write x plus delta x, okay, and y we will keep as it is, minus we will write this function f of xy and upon delta x, okay. So substitute. So in place of x, so here we have x plus delta x whole square into y plus, in place of x, so x plus delta x into y square minus this f of xy, this function as it is, upon delta x. Now we will expand this, okay. So expand this and just multiply this y and this y square inside, okay, and just simplify it. So on simplification, this x square y will get cancelled and this xy square also will get cancelled, right, and what remains is written here. Now take delta x common from numerator, it will cancel with the denominator, and what will remain is limit delta x tends to 0 to xy plus delta xy plus pi square. Now apply this limit. So in place of delta x, write down 0. So this term will be equal to 0. So what we have is 2xy plus pi square. Okay, so this sum we have solved using definition method. Now if you want to solve simply, so fx, that is del f by del x. Okay, so to solve this, so when we are solving with respect to x, okay, so y we will keep constant, okay. So in this, y keep as a constant, so derivative of this x square function is 2x. So here you will get 2xy, okay, plus now again y square will remain constant and derivative of x is 1. So here we have y square. You can check the answer, okay. And suppose if we want to find fy, that is del f by del y. So derivative of function f with respect to y and x we will keep constant. So x square as it is and derivative of y is 1. So here you will get x square plus again with respect to y. So keep x as a constant. So here x will remain constant and derivative of y square is 2y. So here you will get 2xy. Okay. Now next, higher order partial derivatives. Partial derivatives of higher order of a function u is equal to f of x y are obtained by partial differentiation of a first order partial derivatives. So, consider the function u is equals to f of x y. Then we have u x x, that is del square u by del x square, and this is equal to del by del x of del u by del x. So what we have to do, first we have to find del u by del x, and then again we have to take derivative with respect to x. So you will get uxx. Okay, then next one is uyy, that is del square u by del y square. This is equals to del by del y of del u by del y. Okay, so first we have to find del u by del y, and then again we have to take derivative with respect to y. So you will get uyy. Next, uxy. So this we will write as del square u by del x del y. Firstly, keep del by del x as it is into del u by del y. So first here we have to find del u by del y, and then we have to take derivative with respect to x. Okay, next u by x. So this is del square u by del y del x. Okay, so here first we have to take derivative with respect to x, and then we have to take derivative with respect to y. So you will get u by x. Okay, so let's begin with the example. Find the value of del f by del x and del f by del y at point 1, 2 for the function fxy equals to x square plus 3xy plus y minus 1. Also, we have to find del square f by del x square, that is fxx, del square f by del y square, that is fyy, del square f by del x del y, that is fxy, and del square f by del yx, that is fyx. Okay, so let's solve this. So first write down the function. So function fxy given, that is x square plus 3xy plus y minus 1. So firstly we will find fx. Fx is what? Del f by del x. So whenever we will take the derivative of function f with respect to x, y will remain constant. Okay, so derivative of x square is what? 2x plus, now y is constant. Okay, so 3 and y constant, and derivative of x is 1. So here you will get 3y. Again, derivative of y, that is constant, so 0, and derivative of minus 1 is also 0. Next, fy, okay, that is del f by del y, derivative of f with respect to y keeping x constant. Okay, so x is constant, so derivative of this is 0. Again, 3x is constant, derivative of y is 1, so here we have 3x plus 1. Now we have to find that this particular point 1, 2. So fx at 1, 2. So in place of x write down 1, and in place of y 2. Okay, so here you will get 2 plus 6, right? So answer is 8. Again, fy at 1, 2. So again in place of x we have to write 1. Here we don't have y, so just substitute in place of x 1. So here you will get 3 plus 1, that is 4. Next we have to find fxx. Okay, so that is del square f by del x square. So this is equals to del by del x of del f by del x. Okay, so now what is the value of del f by del x? It is given. Here we have solved. It is 2x plus 3y. So here write down 2x plus 3y. Okay, so solve it. So differentiate with respect to x keeping y constant. So this constant term is 0, and derivative of this term is answer is 2. Next we have to find fyy. So this is equals to del square f by del y square. So del by del y of del f by del y. Now del y del y. What is the value of del f by del y? This here 3x plus 1. So write down 3x plus 1. Now here we have to take derivative with respect to y and x constant. So these both the term are constant. So answer is 0. Next, fxy, that is del square f by del x del y. So here we will write as del by del x of del f by del y. Okay, now del by del x as it is. What is del f by del y? 3x plus 1. So write down 3x plus 1. Now take derivative with respect to x keeping y constant. So answer of this is 3. This derivative of this one is 0. Next we have to find f by x. Okay, so f by x is what? Del square f by del y del x. So this is equals to del by del y of del f by del x. Okay, now del by del y into del f by del x, that is 2x plus 3y. Okay, now take derivative with respect to y keeping x constant. So this term is 0 and here we have answer as 3. Okay, now let's begin with the next example. So question is, if u is equal to e raised to 3xyz, then prove that del cube u by del x del y del z is equal to 3 plus 27xyz plus 27x square y square z square into 3 e raised to 3xyz. Okay, we have to prove this. So let's begin with the solution. Here u is equals to e raised to 3xyz is given and we have to find del cube u by del x del y del z. Okay, so firstly we will write in this form, that is del by del x of del by del y of del u by del z. So first we will solve this del u by del z, then we will find derivative with respect to y and then with respect to x. So first let's begin with del u by del z. Okay, so here we have to find derivative with respect to z. So other two variables, that is x and y, are constant. Okay, so the derivative of e raised to 3xyz is what? E raised to 3xyz into 3xy, because here we have to apply chain rule. So derivative of this 3xyz will be 3xy. Okay, next. Now we have to take derivative of this del u by del z with respect to y. So del u by del z, just write down here, that is 3x into e raised to 3xyz into y. Okay, now here we have to take derivative with respect to y. So x and z will remain constant. Okay, so solve it. Now here we have y here also and here, so we will apply UV rule, right? So consider this as u and this as v. So u as it is, that is e raised to 3xyz as it is, derivative of v, that is derivative of y, it is 1 plus this y as it is, and derivative of e raised to 3xyz with respect to y is what? E raised to 3xyz into 3xz. Okay, here we are taking derivative with respect to y. Okay, just simplify this. Okay, so e raised to 3xyz is taken common. So here we have e raised to 3xyz into 3x plus this 3 into 3, it will become 9x square yz. Okay, now we have to take derivative of this term, that is del square u by del y del z with respect to x. So del by del x of this term. Now consider this term as a u and this as v, and then we will apply UV rule. Okay, so e raised to 3xyz as it is, derivative of v, that is 3 plus, here we are taking derivative with respect to x. Okay, so y and z will remain constant. So y and z is constant, 9 is also constant, derivative of x square is 2x. So here we have 18xyz plus this v will remain constant and derivative of u with respect to x. So it is e raised to 3xyz into 3yz. Okay, now we have to do just simplification. So on simplification, that is taking e raised to 3xyz common and simplify it, so you will get the required result. Okay, next topic is mixed derivative theorem. It is also known as Clairaut's theorem. Okay, so let's begin with the statement. If u is equal to f of xy possesses continuous second order partial derivative, that is del square u by del x del y and del square u by del y del x, then both these partial derivatives are same. So statement says that if this function possesses these two partial derivatives, then it will always be same. So let's see example. If z is equal to x plus y raised to x, Then prove that del square z by del x del y is equal to del square z by del y del x. Okay, so here we have to prove this Clairaut's theorem. So z is given, that is x plus y raised to x. Okay, so firstly we will find del z by del x. Okay, so derivative of z with respect to x keeping y constant. So derivative of x is 1. Now here y we are taking as a constant. Okay. So to solve this, here we will apply the formula of d by dx of a raised to x, that is a raised to x into log a, right? So y raised to x into log y. Next we will solve del z by del y. Okay, so here we have to take derivative with respect to y and x will remain constant. So x is constant in this. Okay, x is constant and we have to take derivative with respect to y. So here we will apply the formula of x raised to n, that is nx raised to n minus 1. Okay, so here we will get x into y raised to x minus 1. Make sure here we have taken derivative with respect to y keeping x constant. Next, we will find del square z by del x del y, that is del by del x of del z by del y. Okay, so del z by del y, this is x into y raised to x minus 1. Now we have to take derivative of this term with respect to x. Okay, so on taking derivative, what you will get here, consider this term as a u and this as v and apply uv rule. Okay, so firstly this y raised to x minus 1 is kept as it is, derivative of x, that is 1, plus x as it is, and derivative of y raised to x minus 1 with respect to x. So it will become y raised to x minus 1 into log y. Okay, we have applied this formula. Now we will simplify this. So final answer of del square z by del x del y is equal to y raised to x minus 1 taken common. So it is y raised to x minus 1 into 1 plus x log y. Okay, next we will find del square z by del y del x, that is del by del y of del z by del x. Okay, so del z by del x, that is 1 plus y raised to x into log y. Now we have to take derivative of this term with respect to y and keeping x as a constant. Okay, so take derivative. So firstly this derivative of 1 is 0. So here we have to apply uv rule, right? So consider this y raised to x as u and this log y as v. So y raised to x as it is, derivative of log y with respect to y. So it is 1 upon y plus log y as it is, derivative of y raised to x is what? X y raised to x minus 1. Simplify this, okay, and take y raised to x minus 1 common, so you will get this term. Now you can see that del square z by del x del y is equal to del square z by del y del x. Therefore, this mixed derivative theorem is satisfied. Next one, Laplace equation. A function fxy is solution of a Laplace equation if del square f by del x square plus del square f by del y square is equal to 0. Okay, so if a function fxy to be a solution of a Laplace equation if this condition is satisfied. Next example, determine whether u is equals to ln under root x square plus y square is a solution of Laplace equation or not. So here we will check whether this u is a solution of Laplace equation or not. So for that what we have to do? For that we have to find uxx and uyy and we have to add them and answer should be equal to 0. If this answer is 0, then we can say that it is a solution of Laplace equation. Okay, so let's begin with solution. Here u is given, that is ln under root x square plus y square. Okay, so write down this under root 1 by 2 and bring 1 by 2 here. So here we have u is equal to 1 by 2 ln x square plus y square. Okay, next firstly we will find del u by del x, that is derivative of u with respect to x keeping y constant. So 1 upon 2 as it is. Now derivative of this ln x square plus y square is what? 1 upon x square plus y square into derivative of this term, that is x square plus y square. Okay, again here we have to take derivative with respect to x. So here we have only 2x. This derivative of y square is 0. 2 will get cancelled. So what remains is x upon x square plus y square. Next, del u by del y. 1 by 2 as it is. Again same process. So derivative of ln x square plus y square is what? 1 upon x square plus y square into here we have 2y. Why? Because here we are taking derivative with respect to y. 2 will get cancelled. So what remains is y upon x square plus y square. Next, we will find this del square u by del x square. That is del by del x of del u by del x. Okay, so del u by del x is what? X upon x square plus y square. And we have to take derivative of this term with respect to x. So for that we will apply u upon v rule. Okay, so just simplify this. So here uv rule. So denominator as it is, that is x square plus y square as it is, derivative of numerator, that is 1, minus numerator as it is, x as it is, into derivative of denominator with respect to x. So here we have 2x upon denominator square. Simplify this, so you will get y square minus x square upon x square plus y square whole square. Next, del square u by del y square, that is del by del y of del u by del y. So del by del y as it is, answer of del u by del y is what? Y upon x square plus y square. Now again we have to take derivative with respect to y, keeping x as a constant. So for this again we will apply this uv rule formula. So apply this formula. Denominator as it is, derivative of numerator, that is 1, minus numerator as it is, derivative of denominator with respect to y. So here we have 2y upon denominator square. Simplify this, so you will get x square minus y square upon x square plus y square whole square. Okay, next we have to add them. So add them, okay, and add them and simplify. So you will get answer 0. Therefore, we can say that this uxy is a solution of Laplace equation. Okay. So here what we have studied? We have studied partial derivative with respect to x and y. So whenever we are taking derivative with respect to x, we will keep y constant, and whenever we are taking derivative with respect to y, we will keep x constant. I hope you have understood. Thank you for watching.